So chapter 2 can be a bit tricky in terms of just when you're asked to take a derivative to know what technique to use, because we learned a lot of techniques in the chapter, and all I can say is I'm going to do my best when I write the test to make it as close to this practice test as possible. I'm not going to try to put anything that's different than the practice test. So the best you can, just try to be able to know if a problem looks similar to one on the practice test, what strategy to use to take the derivative. And you should be fine, but there may be a time when you get to the test and you're just not sure what to do, and that's just reality. Hopefully these practice tests are going to minimize the mistakes you make. So problem 1 is probably the easiest derivative to take. We're just going to find the derivative by multiplying the exponent by the coefficient, lowering the exponent by 1. So the first term, 3x squared, I'm going to multiply the 2 by the 3 and get a 6. I'm going to lower the exponent and get 6x to the first, but I probably shouldn't have written that one. The next two terms, I'm going to do shortcut derivatives. To do the derivative of a first power term, you just get the coefficient. Because the second term is minus 5x to the first power, its derivative is just going to be minus 5. And the last term is a constant. Constants have derivatives of 0. So this right here, I used the trick that the derivative of a first power term is just the coefficient. The derivative of a constant is 0. So the answer to the derivative of question 1 is going to be 6x minus 5. I don't need that exponent of 1 there. To do problem 2, I could use the quotient rule to find the derivative, but there really isn't a need to use the quotient rule, and I don't care for the quotient rule, so I'm going to try to avoid the quotient rule. If you want to, you can think of this problem like this. F of x equals negative 3 over 4 times 1 over x squared. This would absolutely be equal to the original problem, because if I was to multiply these fractions back, I'd multiply negative 3 times 1 and 4 times x squared. This is equal to that. And now I can rewrite the 1 over x squared using the rule that says 1 over x to the n equals x to the negative n power. Usually we write the rule going this way, but I can use it using backwards. And so I'm going to rewrite this 1 over x squared as x to the negative 2 power. So now I can rewrite this problem as f of x equals negative 3/4 times x to the negative 2 power. This is a good place to be, because now I can take the derivative real easy. I can multiply the exponent by the coefficient and lower the exponent by 1. So off to the side here, I'm going to write f prime of x. I'm going to start by multiplying the negative 2, which is the exponent, by the negative 3/4. And I'm going to lower the exponent by 1. So I'm going to go negative 2 minus 1. And when I do that, I get negative 3. When you multiply an integer by a fraction, you could cancel the integer with that denominator. So I'm going to cancel these. I'm going to go negative 2 divided by 2 is negative 1. 4 divided by 2 is 2. Now I'm going to clean this up now. I'm going to get f prime of x equals negative 1 times negative 3, which is positive 3 in the numerator of that fraction. What's left in the denominator of that fraction is 2, and then x to the negative 3. This would be a perfectly fine answer for problem 2. Probably not the answer I'll have on my key. On my key, I'm going to use the rule to make this exponent back into a positive exponent. And on my key, I'm going to do an extra step. I'm going to say this 3/2 x to the negative 3 is the same as 3/2 times 1 over x cubed. And then I'm going to multiply the 3 times the 1 in the numerator and the 2 times the x cubed in the denominator to get the fraction down from 2 fractions to 1 fraction. This is probably the better answer, but I live with the first one that I have boxed. But if you would have written 3 over 2x cubed for the derivative, that's a better derivative than the first answer. For problem 3, I'm going to have to rewrite that before I take the derivative. And the rule that I'm going to use to handle problem 3 is something like the nth root of x to the m equals x to the m over n power. And what I'm going to do is get this cubed root of x squared rewritten using that rule. So I'm going to rewrite the problem before I take its derivative. I'm going to write it as f of x equals, the coefficient of 2 is going to stay there, but now the radical is going to turn into a fraction exponent. The exponent under the radical becomes the numerator. The index becomes the denominator. So when I get rid of the radical, I'm going to get 2x to the 2/3 power. Now I'm going to take the derivative, so I'm going to write f prime of x. I'm going to take the exponent of 2/3. I'm going to multiply it by the coefficient of 2, and I'm going to lower the exponent by 1. And the nice way to lower the exponent by 1 is to subtract something that's equal to 1 that has the denominator that I need. So I'm going to subtract 3/3. And 2/3 minus 1, which is the same as 2/3 minus 3/3, will give me negative 1/3. To start cleaning up doing the fraction work, if I'm multiplying a fraction by an integer, I can just multiply the numerator by that integer. And this is going to give me f prime of x equals 4/3 times x to the negative 1/3. If you got this far on the test and gave me this for an answer, I'd live with it. It's like a very weak answer, but it's acceptable. Let me write two answers that are better. I'm going to do something similar to this to get that negative exponent positive. So I can think of this as f prime of x equals 4/3 times 1 over x to the 1/3. Multiply these two fractions to get to one fraction. And get f prime of x is 4 times 1 is 4. And then 3 times x to the 1/3 is 3x to the 1/3. This would be this would be a better answer, but not even the best answer. The best answer would have this turned back into a radical. And to turn that back into a radical, the 4 is going to hang outward and not move. The 3 is going to hang out and not move. I'm going to change the x to the 1/3 into a radical by taking the denominator of the index and putting it, the denominator of the fraction, and putting it in the index, and the rest of this, the x to the first, would go under the radical. This is a third answer. That's the best of the answers, especially if I didn't write that exponent of 1. So for problem 3, anything that I have circled there would be okay. Didn't leave myself enough room to do these problems. Let me do problem 4 in a different color just so it separates from problems 1, 2, and 3. Problem 4, I could use the quotient rule. Anytime you have a fraction, as I did in problem 2, I could use the quotient rule to find the derivative. I don't like the quotient rule, and if a denominator doesn't have any adding or subtracting in it, I can bypass the quotient rule rather easily. When I get on to the next page and do a problem like number 6, I won't really be able to bypass the quotient rule that easily because the denominator has subtraction in it. But in both number 2 and number 4, the denominator doesn't have any subtraction in it. I can rewrite the problem to avoid the quotient rule, and it'll make it a lot easier to take my derivative. So I'm going to rewrite the problem in number 4 by taking both terms in the numerator and writing them over the denominator. That would give me 5x squared over x squared plus 3 over x squared. The 5x squared over x squared, that's easy to reduce. That's just 5. The x squareds cancel. This 3 over x squared, I'm going to be a little bit lazy and just shortcut the simplifying. If I wanted to, this 3 over x squared, I can think of this as 3 over 1 times 1 over x squared, because this would equal to that. 3 times 1 in the numerator would give me this 3. 1 times x squared would give me x squared. And then this I can think of as 3 times 1 over x squared, because 3 over 1 is 3. And 1 over x squared is going to be x to the negative 2. So this is going to be 3 times x to the negative 2 power, or 3x to the negative 2. So this second piece right here, the 3 over x squared, I'm going to rewrite it as 3x to the negative 2 power. Now I've rewritten the problem enough so I can take the derivative. So I'm going to write my f prime of x. The first term doesn't have an x, so it has a derivative of 0. For the second term, I go negative 2 times positive 3 and get negative 6. I lower the exponent by 1, and negative 2 minus 1 is negative 3. So a correct answer for this problem would be negative 6x to the negative 3 is the derivative. I can go through the steps like I did here a couple times to get that exponent written positively, but I'm going to just shortcut this. Let me just write down what it equals to. This, if I did a couple steps that I've kind of done twice on this page, would ultimately reduce to negative 6 over x cubed. That would be the best answer for the derivative for number 4, but it's not required. So for each of the problems that I've done work on here, any of the answers that I have boxed, if that's what you leave on the test for the problem that's equivalent on the test, that would be completely fine. Next page, 4 more problems and they're a little bit harder. For problem 5, there's multiplication, and anytime I have multiplication and both factors have an x, you absolutely can use the product rule to do the derivative. Product rule is a little bit messy, and if it's not that hard to clear the multiplication, it's probably easier to do the derivative without using the product rule. So when I do problem 5, I'm going to FOIL to rewrite the problem and take the derivative after I've done all my foiling. So I'm going to do firsts are x squared times 3x, which is going to be 3x cubed. Outers are x squared times minus 1, which is minus 1x squared. Inners are 6x times 3x, and that's 18x squared. And last are 6x times minus 1, which is minus 6x. If I combine the outers and the inners, I can rewrite this problem as f of x equals to, the first term is going to be 3x cubed, middle term is going to be positive 17x squared when I combine the outers and the inners, and the last term is minus 6x. I'm going to do the derivative now, so I'm going to write my f prime of x, and I'm just going to multiply the exponent by the coefficient and lower the exponent by 1. So the first one, I'm going to go 3 times 3 is 9. I lower the exponent from x cubed to x squared. Second one, 2 times 17 is 34. I lower the exponent from x squared to x to the first power. Last term is an x to the first power, and the derivative of any x to the first power term is just its coefficient of negative 6. This is the answer that I'm going to write for problem 5. If I used the product rule, I would get exactly the same answer. So if you did this problem before watching the video and you used a different strategy, if you didn't get the same answer, then you didn't do it right. You made a mistake somewhere in your calculus. 6 is ugly because I have to use the quotient rule. So because there's a fraction and the denominator has a minus, I'm going to use the quotient rule. I'm going to jump right into it, and I'm going to explain what I'm going to do. The derivative I'm going to get by taking the denominator, which is 3y minus 5, times the derivative of the numerator, which is going to be the derivative of y squared, then minus the numerator, which is y squared, times the derivative of the denominator, which is 3y minus 5, all over the denominator squared. So this is a template for using the quotient rule. I'm going to have to take two derivatives. They're easy derivatives. The derivative of y squared is going to be 2y, and the derivative of 3y minus 5 is just going to be 3, because the first term is a first power term. The derivative of a first power term is its coefficient. The second term doesn't have a letter. The derivative of terms without letters are 0. Let me write this down now. So I'm going to write g prime of y equals, and I'm going to leave the denominator alone. I'm not going to do anything fancy with the denominator the whole way through. It's just going to stay in my answer. For this piece right here, this piece is going to be 2y times 3y minus 5. And I'm going to go ahead and do that multiplication. I wrote the 2y over here because multiplication is commutative. The first thing I'm going to write in my numerator is what 2y times 3y is, which is 6y squared. And then what 2y times minus 5 is, which is minus 10y. The next part of my numerator, I have this 3 times y squared, and I'm just going to write that. I'm going to have the minus sign, and I'm going to write the 3 first and the y squared second. Now in the numerator, I'm going to combine the like terms. The like terms in the numerator are this 6y squared and that 3y squared. This is going to give me g prime of y equals 6y squared minus 3y squared, which is 3y squared, and then minus 10y over 3y minus 5 quantity squared. This would be an absolutely adequate answer. If you stopped there, I would live with it. If you were clever and noticed that there was a common factor of a y in the numerator and you factored out that common factor, that would be better. That's probably what I'd have on my key. So for problem 6, both of those answers would be okay. Problem 7, I see a parentheses with an exponent, so I know at some point I'm going to have to use the chain rule. There's a number in front of the parentheses with the exponent, but that number doesn't have a letter, so I won't have to do the product rule in addition to the chain rule. When I get down to problem 8, I see a parentheses with an exponent, so I know I need to use the chain rule, and what's in the front of the parentheses has a letter, so I'm also going to have to use the product rule. 8 is going to be both product rule because I'm multiplying two pieces that both have an x, and chain rule because there's a parentheses with an exponent. 7 is chain rule because there's a parentheses with an exponent. There's no product rule because one of the two pieces that's being multiplied doesn't have a letter. Super easy to do 7 compared to 8. So I'm going to write g prime of t. I'm going to take the 5, multiply it by the 2, leave myself some room. I'm going to lower the exponent from 5 to 4, and where I left that room, I'm going to put the derivative of each term inside the parentheses. The derivative of 4t, because it's a first power term, is just the coefficient of 4, and the derivative of minus 3, because it doesn't have a letter, is 0. So the derivative of 4t minus 3, which went in that space that I left, is going to be 4. And now I'm just going to multiply the numbers out and get an answer that's as simplified as I can actually do. So 5 times 2 is 10 times 4 is 40. So I'm going to get 40 times 4t minus 3 to the 4th. And that's all there is to do for number 7. Number 8 would be sometimes a disaster when I do these problems like this on a test. 8's a product rule. There's multiplication. And when you have multiplication and it's hard to clear the parentheses, you have to use the product rule. And to do the product rule, you have to take each piece that's being multiplied, multiply it by the derivative of the other piece. So to do the product rule for number 8, I have to do two derivatives. I'm going to have to do the derivative of 4x cubed times the 5x plus 3 squared unchanged. That's what I wrote second. And I'm going to have to take the 4x cubed times the derivative of 5x plus 3 squared. There's two pieces being multiplied, 4x cubed and 5x plus 3 squared. I need the derivative of each one of those pieces. There's the derivative of 4x cubed. There's the derivative of 5x plus 3 squared. There has to be a plus sign between, and then the derivative is multiplied by the other piece. Let me now try to handle these derivatives. So I'm going to write y prime. I should have written y prime before. Y prime equals, and for this first piece, I'm going to leave the 4x cubed, and when I go to do the derivative of the 5x plus 3 squared, I'm going to bring the 2 out in front of the parentheses. I'm going to leave myself some room. I'm going to bring the exponent down to 1. And where I left some room, I'm going to multiply by the derivative of the two pieces inside the parentheses. The derivative of the 5x inside the parentheses is 5 because the derivative of any first power term is its coefficient. The derivative of the 3 inside the parentheses is 0. So the derivative of 5x plus 3 squared is going to be 10 times 5x plus 3 to the first. That's what I'm going to write right next to my 4x cubed. I'm going to write 10 times 5x plus 3 to the first. I'm going to bring this plus sign down. I'm going to bring this 5x plus 3 squared down. And after the 5x plus 3 squared, I'm going to write the derivative of 4x cubed, and that's easy for me. I go 3 times 4 is 12, and lower the exponent by 1 to x squared. Now I'm going to try to simplify this, and let me multiply this 4 and that 10, and maybe write that in a better order. So this is going to give me y prime equals 4 times 10, which is 40. I'm going to leave the x cubed and the 5x plus 3 alone. And then this next piece, I'm going to have 12x squared, and I'll write that first, and then 5x plus 3 quantity squared second. Now I'm going to go for common factors. Between this 40 and that 12, they're both divisible by 4. I'm going to pull out a common factor of 4 for those. I'll leave myself some room here for a second. Between this x cubed and that x squared, I'm going to pull out a common factor of x squared. And between this 5x plus 3 to the first and this 5x plus 3 to the second, I'm going to pull out a 5x plus 3. I didn't really leave myself room to do that. Let me get another sheet of paper. So what I'm trying to write here is y prime equals to 4 x squared times 5x plus 3. That's my common factor. And what I'm going to be left with from this piece, from the 40, when I take out a 4, 40 divided by 4 is 10. From this x cubed, I took out 2 x's, so I'm left with 1x. I took out that 5x plus 3 entirely. Done with this term, I'm going to bring this plus sign down. From this 12, I factored out a 4, so I'm going to divide 12 divided by 4 and get a 3. I took out this x squared completely, so I don't have to worry about it. There were 2 5x plus 3s, and I took out 1 5x plus 3, so I'm left with 1 5x plus 3. Basically done. I'm just going to clean up this parentheses. Inside this parentheses, I see 10x plus 3 times 5x plus 3. The 3 times the quantity 5x plus 3 is going to come out to 15x plus 9. And I'm about to write something that I'm going to call my answer. I'm going to say y prime equals to 4x squared times 5x plus 3, and then 10x plus 15x is 25x, and then the plus 9. I don't think there's a thing I can do to make that better, and I don't think there was anything earlier that I would say, though, this is a good enough answer. So we're going to go ahead and call that done. Just 2 more problems to do for this part of the review. Problem 9 gives me an equation and a value of x, and first it asks me to find the slope of a tangent line. Really easy to find a slope of a tangent line. You just find the derivative and plug that value of x into the derivative. So to get problem 9a done, first I'm going to find the derivative. The derivative of x squared is 2x to the first. The derivative of 3x, because it's a first power term, is just a coefficient of 3. The slope, which I'm going to write as m, of the line that we're worried about, we get by taking the value of x that's given and we plug it into the derivative for the x. And so m is going to be negative 4 plus 3. The answer to part A, the slope of the tangent line, is m equal to negative 1. When I go to do part B, it wants me to find an equation for a tangent line. And in order to find an equation for a tangent line, I need 2 things. I need a point, and I need a slope. Slopes I get by plugging numbers into the derivative. I've already done that. The x-coordinate of the point was given to me. The y-coordinate wasn't given to me. Y-coordinates of points are gotten by plugging x's into the original function. So my y, I'm going to get by plugging negative 2 in for that x, and negative 2 in for that x. The y-coordinate of the point is going to be negative 2 squared plus 3 times negative 2. That's going to give me y is 4 minus 6. That's going to give me y equals to negative 2. probably not so good that I get the same x and y, but I just did. I'll live with it. Now I have a point and a slope, and once I have a point and a slope, I can get an equation for a line by using y minus y1 equals m times x minus x1. And for the y1, I'm going to plug the y coordinate of the point, which is going to be -2. And for the m, I'm going to plug my -1. And in for my x1, I'm going to plug that -2. I'm going to simplify this. On the left side, the double negative goes positive. Similarly, on the right-hand side, the double negative goes positive. I'm going to clear the parentheses on the right-hand side by going -1 times x, and I'm going to write that as -1x. And then -1 times 2, I'm going to write that as -2. I'm going to get my answer by subtracting 2 and solving for y. On the left-hand side, when I subtract 2, I'm left with the y. On the right-hand side, because both the numbers have the same sign, I add the numbers and keep the sign. So the 2's are both negative. I'm going to add the numbers and keep them negative. The answer to part B of number 9, the equation of the tangent line, is going to be y equals -1x minus 4. Ten is a little bit trickier. 10 wants me to find values of x where the tangent line is horizontal. This is similar to saying find all values of x where f prime of x equals to 0. Well, it's also similar or equal to saying find all values of x where the tangent line has a slope of 0. All these mean the same thing, and all three of those, all they ask me to do is take the derivative and set it equal to 0. So to do part A, I'm starting to get messy here. Let me pull in another color. I'm going to find the derivative of this. The derivative of x squared, I bring the 2 out in front and get a 2, lower the exponent by 1 and get a 2x to the first. The derivative of 8x is just 8 because the derivative of any first power term is its coefficient. The derivative of minus 4 is 0 because it doesn't have an x. To answer the question to part A, I take the derivative and set it equal to 0. And I do the algebra that's necessary, and the answer to part A is going to be x equal to -4. That's what I get when I find the derivative and I set it equal to 0. Done with part A, I'll move on to part B. Part B wants me to find the equation of the tangent line, and to find an equation for a tangent line, I always need a point and a slope. The x-coordinate of my point is going to be -4. And because I'm finding an equation of a horizontal lines have 0 slope, the slope of my line is going to be 0. That's the kind of tricky thing that was not given but implied by the word horizontal. I need to get the y-coordinate of my point, and I'll get the y-coordinate of my point by plugging in -4 for this x. So I'm going to go y equals -4 squared plus 8 times -4 minus 4. Kind of not in the mood to do that by hand right now, so let me pull out my calculator and go -4 squared plus 8 times -4 minus 4, and I get -20. So the y-coordinate of my point is going to be -20. So I have both a point and a slope now, and I'm going to use the formula y minus y1 equals m times x minus x1 to get my answer. In for the y1, I'm going to plug -20, so I'm going to get y minus -20. And in for the m, I'm going to plug 0. In for the x1, I'm going to put a -4. So I get y minus -20 equals 0 times x minus -4. This would simplify to y plus 20 equals 0 times x plus 4. If I cleared the parentheses, I'd go 0 times x, which is 0, and 0 times 4, which is 0. So the parentheses on the right-hand side simplifies to just 0. I'm going to minus 20 from both sides, and I'm going to get my answer. That answer I can't write right there. Let me just box it in and write it right here. On the left-hand side, when I subtract 20, I'm left with the y. On the right-hand side, 0 minus 20 is negative 20. So that's the answer to part B of number 10, and that's the end of part 1 of the chapter 2 practice test. And now we need to get this perfected before we go on, because the second part of the chapter, if you don't have the first part really have a firm understanding of the first part, it's going to make it kind of hard to do the second part. So don't move on to the second part till you feel good about all the problems on this practice test.